Rohit and Sriram, Praveen, Alia. Very, very good evening. I am doing good. My health is good. Sriram, thank you. It is better. Feeling good. Rohita, yes, good evening. Very good evening. Good evening, Mallikarjun. Hello, Gopi. Victorial. You keep your real names here. Yashwant. KT Vlogs. Hisar. What is Hisar? Manush. How do you know Hisar? Hasini, Anivesh. Very, very good evening. Gopi. Pranav. Khalil. Lasya. Rani. Thank you, Darsh. Thank you, Devil Potter. Good evening, everybody. Good evening. Sushila, good evening. Akshaya. Yes, Charit. Yes, Charit. These classes are not your real classes. These are just a bridge course, as the name suggests. Just giving you a bridge to go from 10th to 11th. 10th has not started, 11th has not started yet. This is 10th class. This is 11th class. This is the bridge. You are here. You are here. I am here today. So it's a extra head start that you have, apart from other students, those who are not preparing here. Sushant, that is a secret. Good evening, Amruta. Good evening, Aparao. Akshara, yes. Yes, same thing will be taught again. Yes, correct. Everything will be taught again. Okay, so let us start our class. Okay, everybody. Today I have got two topics for you. Topic 1 for today is stoichiometric calculation, like we did yesterday, the limiting reagent topic. Same way as limiting reagent, one more complication we'll add today, topic 1, which is stoichiometric calculation involving percentage purity of reactants. Percentage purity of reactants. Okay, this is the first topic that I'm going to introduce today. Most of you do a lot of mistakes in this topic when students try to attempt the question. Many times they do a mistake. But today I will tell you this topic in a trick manner. Okay, in a trick way we will do this so that never ever you do any mistake. Okay, never ever you will do any mistake once you know this trick that we will do. And after completing this, we'll go for topic 2. Second topic for the day will be percentage composition. So mostly we are going to deal with percentages today. Percentage composition of elements in any compound. That means whenever you take any compound, in that compound, how much percentage of this A element is there, how much percentage of B element is there. Okay, so that is what we are going to study today, these two things. For example, when I take methane, in methane, you will find that 75% of the mass of methane is carbon. So there is 75% carbon in methane and 25% hydrogen in methane. This is the percentage composition of methane. This is called as percentage composition, means in a particular molecule, how much percent, I'll tell you, Venkat. 20 liter was the answer for yesterday's question, Venkat. At the end, okay, at the end we'll do. Okay, now, so percentage composition means in methane, how many grams of carbon, how much percent of carbon by mass, how much percent of hydrogen by mass, it will come out to be 75 and 25 for different elements we'll see today. So let's do these two topics. First one is percentage purity related problems. Percentage purity related problems. See, many times what happens is, whenever we are doing any reaction, okay, many times our reactant is not pure. It has some impurity inside it. It has some impurity inside it. So how much is that impurity is what they are going to ask. What is the percentage of purity? What is the percentage of impurity? Okay. Now see the trick first, then we will start doing the problems. Okay. You see the trick first, then we'll start doing the problems. All of you please quickly see here. Trick is simple. Whenever there is a problem in purity of reactant, always product will be formed lesser than expected. You can close the chats. Product will be formed lesser than expected. Okay, product will be formed lesser than expected. So trick is simple. Whenever there is a percentage purity related problem, first point you write it down. Product formed will be lesser than expected product. Lesser than expected product. Always, whenever there is a purity problem, product form will be lesser than expected. For example, see a simple example. If I say our reaction is, simple daily life example I'll take. If you study for 2 hours, you get 100 marks. That is your reaction. When we study 2 hours, then we get 100 marks. This is a perfect scenario when your study is 100% pure. When your study is 100% pure study, 2 hours of study give you 100 marks. Simple. 4 hours of study should give you 200 marks. 6 hours of study should give you 300 marks. 8 hours of study should give you 400 marks. Now, if I say you are studying for 4 hours, you are studying for 4 hours, how many marks will you obtain if your study is 50% pure? If your study is 50% pure, the meaning of this is half of the time you sleep off. Although the books are open, but half of the time you sleep off. How many marks you will get? Let us see. Our expectation was 2 hour study give you 100 marks. So I was expecting that when my student has studied for 4 hours, he should get or she should get 200 marks. This was your expectation. This was expectation. But will you actually get these many marks? Answer is no. Sir, 4 hours I am studying, only 50% of the study is pure. That means out of 4 hours, 2 hours so you are sleeping only. So only you will get 2 hours ka marks, which is 100 marks. So your actual marks is only 100. Actual marks is only 100. 100 marks are the actual marks. Okay, so what happened to the product? Product got decreased. Same problem happens when the reactant is not pure. If reactant is only half pure, half the amount of product only you will get. You will not get the full product. Okay, so this is the one. Same way if I take calcium carbonate, you can see here everybody. This is 100 grams of calcium carbonate sample. 100 grams of calcium carbonate sample, but it is 50% pure. Means out of this 50 gram is sand only. 50 gram is only sand, means impurity, which will not react. Rest 50 gram only is calcium carbonate. Okay, so when I get the product, CaO plus CO2 product, I'll not get it according to 100 gram, I'll get it only according to 50 gram. So product will be formed lesser than expected. I hope this point is clear to everyone. So once you have written this, then you can write the formula. You can just say that actual product equal to expected product into percentage. So 200 into 50% when I do 200 into 50 by 100, 200 into 50%, I get the actual product. So remember the formula now. Product obtained actual will be expected product into percentage. Product expected into percentage by 100. This is the first formula, remember. It's a trick that I am telling so that you never do a mistake. You don't forget that should I divide by percentage or should I multiply by percentage. You should never be confused in that. First thing I have told you as a trick, whenever there is a percentage problem, your product will be formed lesser than expected. Next important trick point is reactant has to be taken more than expected. Write it down. Reactant taken will be more than expected. Will be more than expected. I'll show you the result here as well. So now I say that beta, you want to get 300 marks. You want to get 300 marks. Then how much you should study if your study is 50% pure? You want to get 300 marks. How much should you study? How many hours should you study so that you get 300 marks, but your study is only 50% pure? Then you will think, sir, what I will think is that 100 marks come from 2 hours, 300 marks should come from 6 hours. This was my expectation. So my expectation was 6 hours. 6 hours was expected reactant. But now you know 50% of the time you are sleeping only. That means if I take you 6 hours of study, if you do 6 hours of study, out of that 3 hours you will sleep. Rest 3 hours only you are awake, no. So the marks you will not get 300. In 3 hours you will get only how much? 150 marks. But you want how many marks? 300 marks. So you have to study for 12 hours. You have to study for 12 hours, double the amount you have to study. Because half the time you sleep. So for 300 marks, you can't study for 6 hours. Now you have to study for 12 hours. You have to study more. So always you will have to study more when you are, okay, again, it's a simple thing, no? Whenever your study is not pure, you are sleepy in between. You have to study for more time to get good marks. Correct? You have to study for more time to get good marks. So study is a reactant. You have to study for more time. So 12 hours is the actual answer. Actual reactant is always higher than expected. Actual answer is always higher than expected. Again, I am telling very simple now. So whenever they ask you the amount of reactant required, your answer should be more than expectation. Whenever they ask you the amount of product formed, your answer must be less than expectation. So when you want to get good marks, but your study is 50% pure, you have to study a lot. Okay. And when your study is 50% only pure, then whatever time you study, you will get always lesser marks than expected. Always lesser marks than expected. So for the reactant, the formula is reverse. When you want to increase your reactant, you divide by percentage. So expected was 6 hours. When I do 6 hours divided by 50%, 6 hours divided by 50% when I do, then it becomes 12 hours. Then it becomes 12 hours. So what you do? You divide by percentage. So you write down second formula. Second trick formula is going to be this. That's all. 2 trick formulas. Reactant actual should be expected reactant. You will not find this formula anywhere. Okay. Books will solve it by unitary method. You can also solve it by unitary method. I'll show you, but then you will get confused there. Many of you will use the wrong formula there. You will decrease the reactant sometimes, you will increase the product sometimes, and all question will go wrong. Okay. All questions will go wrong. So please see here. So if we want to increase the reactant, so actual reactant should be more value. Should be more value. How to increase it? Divide by percentage. Divide by percentage into 100. Okay. So this is the one. Always I will try to decrease the product. Always I will try to increase the reactant. Just say this to yourself. Say this to yourself and write somewhere on the notebook as well. Whenever there is a percentage purity related problem, percentage purity related or percentage yield related, both mean the same thing. Yield or purity both mean the same thing. Both same thing you have to do. I will always decrease the product. I will always increase the reactant. I will always decrease the product. I will always increase the reactant. To decrease the product, multiply with the percentage. To increase the reactant, divide by the percentage. Okay. Now we will start with the questions. Now see everybody carefully. Before I start with the first question, I want everybody to like the video. 44 likes are there, 315 people are watching. I have to say this to you every day. Don't do like that. Like the video, then we are going to move ahead. Don't worry about the formulas, learn the concept that I am telling. Whenever there is a problem in your reactant, you will always get lesser product. Whenever there is a problem with the reactant, you have to take a lot of reactant to start the reaction. Okay? So whenever you are sleepy, you will have to study more and you will always get lesser marks. You will always get lesser marks. You have to study more to perform well. All right. Okay, guys. So 3 types of questions can be asked. 3 types of question. First, you can look at which type they're asking. So 3 types. Type 1, type 2, type 3. Type 1, I will give you percentage. I will give you reactant. I will ask you product. First type, you will try to decrease the product. Second type, I will give you percentage. I will ask you reactant. I will give you product. Okay, that reaction is 50% happening and product is this much. How much reactant should be taken? Third is, I will ask you percentage. I will give you reactant and product. I will ask you what is the percentage purity of reactant if this much reactant produces this much product. 3 types of question. One by one, we will solve. Carefully see. First type, type 1. So I'll give you percentage, I'll give you reactant, I'll ask you product. Question is like this. Write down the question. Calculate the mass of carbon dioxide gas. Calculate the mass of carbon dioxide gas evolved when 20 grams of 40% pure magnesium carbonate sample is heated. Okay, this is the type of question you are getting. How to start? See here, everybody. Whenever any percentage is given, you first ignore the percentage. You don't think that how much percentage is given. Ignore it. You think if 20 gram was proper MgCO3, then how much product I should obtain? That is going to be your expected product. Expectation. Then decrease it by multiplying by 40%. Finish. That's all. You do the problem normally, like the first type of problem we did, simple type. That 20 gram MgCO3 produce how much CO2? That is expectation. At last you decrease your product because product is a CO2 here. So I'll write the reaction first. MgCO3 breaks down in the same way as calcium carbonate. This is our reaction. MgCO3 gives magnesium oxide solid and CO2 gas. Okay, this is our reaction. So step 1, what you will do? Step 1, write down. Step 1, find expected product. Because CO2 is a product, I am calling it a product. Find expected CO2. Normally do the question. Okay, how to do the question? We did the first type of question, balance it 1 mg, 1 mg, 3 oxygen, 3 oxygen. So 1, 1, 1 is the stoichiometry. It's not a limiting reagent question. There are no two things given. Only MgCO3 is given. So 1 mole MgCO3 produce 1 mole CO2. In terms of weight, MgCO3 molar mass is 84 grams. MgCO3 molar mass is 84 gram. You can check it how. Magnesium molar mass is 24 gram. Carbon is 12 gram. Oxygen is 16 gram. So when you add MgCO3, you will get 84 gram. So when I take 84 grams of MgCO3, I get 44 grams of CO2. This is our reaction is telling us. So 84 gram gives 44 gram. 20 gram should produce how much? What is our expectation? Let us see. So we'll say 84 gram of magnesium carbonate produce, I'll do by crisscross method, everybody. Okay, I'll do it by crisscross method. I'm keeping MgCO3 here and I'm keeping CO2 here. So when MgCO3 is 84 gram, CO2 was 44 gram. When MgCO3 is 20 gram, CO2 will be x gram, crisscross. So our expectation is x times 84 equal to 44 times 20. So x comes out to be 44 into 20 by 84. Okay, on the table of 4 I can cut it. On the table of 4 it goes at 21, it goes at 11. So this is almost coming out to be just less than 11 gram. Okay, so our expectation was around 11 gram because 20 and 21 will almost cancel out each other. So it is almost coming out to be just less than 11 gram. Just less than 11 gram. So just I'll write this value. This is 220 over 21, which is 10.4 gram. This is not your answer. Okay, this is our expectation. But now because CO2 is a product, I told you the trick. Answer that amount of CO2 that you will get will not be this much because if this 20 gram was not 100% pure. Out of it, mostly half of it is sand only. So actually this is not pure 20 gram. In this, only let's say 8-9 gram will be pure MgCO3. So product will be much lesser than this. So how much will be the product obtained? It will be only 40%. So we'll say actual CO2. The answer that is expected CO2 into 40%. So 10.4 into 40 by 100. Okay, which comes out to be 4.16 grams. 4.16 grams. This is your answer. Weight of CO2 obtained is only 4.16 gram. I have explained it very slowly. I hope it is clear to everybody. Okay, I'll open the chat for 2 minutes. I hope it is clear to everybody. If it is clear, crystal clear, just write crystal clear. Then we'll move ahead. Sir, can you open the chat? If it is clear to everybody. I'll wait for your reply. Crystal clear. Very good. Good. Clap for yourself. Once again, not yet, I'll explain Pushpa. Please watch the video again, beta. Okay. Very slowly only I've explained. So don't go out of the class and come in the class, go out of the class, come in the class. Stay in the class, understand everything carefully. Good. Good. So are you ready to do one question yourself? Are you ready to do one question yourself? So I'm giving it here. Now one question you do. One question you do. Okay. I have written this question here. You can see how I have done. I want you to do one question now. Question is, I'm writing the question here, okay? I'm writing the question here. This is your question. Calculate the volume. Calculate the volume of ammonia gas formed when calculate the volume of ammonia gas formed when 5.6 grams nitrogen gas reacts with excess of hydrogen gas and reaction yield is 60%. Reaction yield is 60%. Okay, yield means after 60% reaction stops. It is same problem as the other percentage. So purity given, yield given, you treat it same way. Now you do this yourself. Calculate the volume of ammonia formed at STP, standard temperature pressure. What is the volume of ammonia formed at STP when 5.6 grams when 5.6 gram nitrogen react with excess of hydrogen. 1 minute I'll give you. Kushal says 6.72 liter. Kushal says 6.72 liter. Kumara says 5.3 liter. I'll just keep writing the answers that you are saying, okay? Prince also says the same. Ashwita, you'll have to watch the video once again then. Okay. Prince has changed the answer to 6.8. 5.3, I am getting few answers. Thanu says 0.79. Okay. Thanu says 0.79. So many are saying 5.3. I am considering 5.3 is most of you are getting, might be correct. Now let me solve. Okay. Now let me solve. All of you can see here. If it is not clear, you see the next question. No, every question is going to be solved in same way. Calculate volume of ammonia formed. So I'll write the reaction first. N2 gas plus H2 gas. Yesterday I balanced it. N2 plus 3H2 give 2NH3. This was the balancing. Okay, so first I am finding the expected amount of ammonia. Because ammonia is a product. Ammonia is a product. My answer will be lesser than expectation. So I am writing the mole concept. I am saying 1 mole of this reacts with 3 moles of H2 to give 2 moles of ammonia. Now already they have given you that 5.6 gram nitrogen react with excess of hydrogen. So they have given you that limiting reagent is nitrogen only. Hydrogen is the excess. You can ignore this person. He is the limiting reagent. Directly they are telling. One person is excess. It's almost like saying I am giving you 2 cheese and infinite number of breads. Make sandwich. You will say I'll make 2 sandwiches. So directly given limiting reagent is nitrogen. Mole concept says that when this is 28 grams, then this is 2 mole. 2 mole means 2 times 22.4 liter. 28 gram produces 2 into 22.4 liters. So first I am finding step 1 expected ammonia. Expected ammonia. So I'll say that when nitrogen is 28 gram, then ammonia is 44.8 liter. And when nitrogen is 5.6 gram, ammonia is x liter. Cross multiply. Cross multiply. So we get 28x equal to 5.6 times 44.8. Okay. This exactly goes 4 times. Okay. This exactly goes 5 times, not 4 times, 5 times. Okay. 2.8 ka double is 5.6. So it will go at 5 times. You can check. So x comes out to be 44.8 upon 5 liter, which is 8.94 liter. This is not our answer. This is our expectation. This will be the first option. Don't tick it. This will be the first option. Do not tick this option. Okay. Then we have to go for the real answer. We know that ammonia is a product, so ammonia will be formed lesser than expected. So actual ammonia will be lesser than 8.9, so which will be 8.94 into 60%. So that is absolutely correct. Those who have got 5.37, it is correct. 5.37 is correct. Thanu is clear with it. Are all of you happy with this question? Are all of you getting the answer, yes or no? Are all of you happy with this? Getting the answer? 5.3, because this is almost 9. 9 6 are 54. 5.4 around you are getting. So 5.37 liter is the volume of ammonia as the answer. Yes, good. So options will be like, let's say option 1 is 8.94, option 2 is like 10.6 liter, option 3 is like 18 liter, option 4 is like 5.4 liter. So you can directly get the answer also. As soon as you find your expectation, then you see, oh, it's a product. Product should be less than 9. Less than 9 means only option is 5.4. So you can directly tick it also. Because other options are to bigger. Other options are to bigger. Now another question. Now this time I'll ask you reactant. So you increase the reactant. Will you do yourself, yes or no? Will you do yourself? I'll do the second type of problem now. You do. Okay. I'll ask you reactant now. You increase the reactant. Will you do, yes or no? If you will do, just say I will. Just say I will and like the video quickly. Just say I will and like the video. Yes. Okay. Another question. This time, this is second type, which is I am asking you reactant, I'm giving you percentage, I am giving you product. Question is this. What mass of 80% pure methane gas must be combusted, means undergoes combustion, to produce what mass of 80% pure methane must be combusted to produce 4.2 into 10 to the power 23 molecules of water. Think yourself, everybody. I'll give you 2 minutes to solve. I'll give you 2 minutes to solve it. I'll give you the options as well. I'll give you the options as well. Okay, first you try to do yourself. Very good, very good, very good. Correct, correct, correct. All of you are getting good answer. Very good, everybody. Very, very good. I'm impressed. I'm impressed. So option is 5.6 grams. Option is 4.8 grams. Option is 6.9 grams. And option is 4 grams. Okay, these are the options. Time up. And 6.9 everybody is getting. Clap for yourself. Clap for yourself. All of you have done correct. Is it an easy method, yes or no? Is it a very easy method, yes or no? Is the trick easy, yes or no? If you like the trick, you can say it is easy. You can say it is easy. Mention in the chat box if you like the trick. Is it easy? Is it making your life much simpler? Yes, good. So all of you are getting correct answer. Very good. 6.9 is the correct answer. 6.9 is the correct answer. Yes, good. Let us start. So question is combustion. Methane gas plus O2 gas giving you CO2 gas plus H2O liquid. Then we did the balancing in the last class for the same reaction. 4 hydrogen, so I'll make it 2 water. And now oxygens are 4 here, so I'll make it 2 O2. 1, 2, 1, 2, this is the stoichiometry. 1 mole react with 2 mole to give 1 mole and to give 2 mole. Now our comparison is between mass of methane versus molecules of water. First, I'll neglect this 80% pure. Ignore. Ignore. I'll just say when methane is 16 grams, then water molecules are 2 Na. Means 2 into 6 into 10 power 23 molecules. Okay. So this is the case. 16 gram gives you these many molecules. So expectation I'm checking first. Step 1, expected CH4, which is a reactant here. Okay, don't forget it's a reactant. So my expectation was that how much I should have taken was, I'll say when CH4 is 16 gram, then water molecules are 12 into 10 power 23 molecules. When CH4 is x gram, then water molecules will be 4.2 into 10 power 23. These many. Now cross multiply. So our expectation is x. So we get 16 times 4.2 into 10 power 23 equal to x times 12 into 10 to the power 23. 10 की power 23 cancels out. 10 की power 23 cancels out. So x comes out to be 16 into 4.2 by 12. Okay, on the table of 6 I am cutting. 6 sevens are 42. So this is 0.7 times. This is 2 times. Now 8 times I am cutting it. 8. 8 7 is 56. So 5.6 gram was expectation. but because the reactant is not pure. Harita, what is your doubt? I didn't see your doubt. Okay. So our reactant is not fully pure, so I have to take a lot of it. I have to study more. Correct? So how much do we get? How much do we get? So we say actual CH4 must be greater than 5.6 gram, which is 5.6 gram by 80%, which is exactly 7 times 7 gram. This is the answer. This is the answer. Okay. Harita, why should we consider Avogadro number here, sir? Beta, because they are not talking about moles, they are talking about molecules. They have given you the water molecules are these many. So water molecules in 2 mole is 2 Na water molecules. Okay. So I hope this is clear to everybody. Shall I give you one more? You want to do one more? Do you want to do one more? Yes. So last question we'll do now. Question is, yes, question is, now I am giving you reactant, I am giving you product, I am asking you percentage. Okay. So they are saying 20 grams of calcium carbonate, 20 grams of calcium carbonate sample on reaction with HCl, on reaction with excess HCl produces 20 grams of calcium carbonate on reaction with excess HCl produces 1.1 gram CO2 gas. Find percentage purity of calcium carbonate sample. Find percentage purity of calcium carbonate sample. Find percentage purity of calcium carbonate sample. Reaction is this: CaCO3 solid plus 2 HCl give CaCl2 plus H2O plus CO2 gas. This is the balanced reaction that I have given you here. Do the question. I'll give you a hint. Okay, I'll give you a hint. You think if 20 gram was 100% pure, what was your expectation? How much CO2 should have been obtained? See your expectation. Let's say your expectation was very high. Then this is the actual CO2 produced 1.1 gram. So you have the actual product, you have your expected product, you find the percentage. Find the percentage. I'll give you the options. %, 75%, 25%, 20%, 12.5% as well. One option is 12.5% as well. 50, 12.5%, 25%, and 20%. 50, 12.5, 25, and 20. 12.5%. Very good. Clap for yourself. Sasideep, Charani, Ashwin. Clap for yourself. Venkateshwar, Lakshmi, Asif, Akshara, Pinky, not correct, Pinky. Some problem. Okay, Chalam, Ramakrishna, very good. Clap for yourself and like the video. 12.5 is the correct answer. Very good. So first I'll check, if I took 20 gram of CaCO3, then what is my expected CO2? So step 1, I am finding expected CO2. Expected CO2 I am finding. Okay. So to find the expected CO2, I'll look at the stoichiometry of the reaction and I'll say, when this is 1 mole, CO2 is also 1 mole. So when this is 100 grams, CO2 is 44 grams. 100 gram produce 44 gram CO2. So when CaCO3 is 100 gram, CO2 is 44 gram. When CaCO3 is 20 grams, then what is my expectation X? So we say 20 times 44 equal to 100x. X is 88 gram. 8.8 gram. 8.8 gram. This is expectation. Expectation. But obviously reality has to be lesser. Reality has to be lesser. So reality is only 1.1 gram. This is actual CO2. Now for the product, I told you that actual product equal to expected product into percentage by 100. So I get actual product is 1.1 gram. Predicted product, expected product was 8.8 into percentage by 100. So percentage comes out to be 1.1 by 8.8 into 100, which is 100 by 8, which is 12.5%. Just clap for yourself quickly. You have done the answer correctly. Is it clear for everyone? Yes or no? Is it clear to everyone? Just reply it is clear and say bye-bye. I'll see you all in the next class. If it is clear, just write a crystal clear if all the 3 types of questions are clear to you. 3 types of questions we have done today. If they are clear to you, just write a crystal clear and I'll see you all in the next class. Quickly. Okay. It is clear. Good. All right, everybody. Then bye-bye. Thank you. See you all tomorrow. Day after tomorrow.